What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So, let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock, because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans, because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So, if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. So? Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact. All of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it.
Sand is everywhere. In your eyes and mouth, in your hair, under your t-shirt, and in your shoes. You can hardly stand. The wind is so strong, it's knocking you down. Suddenly, an especially powerful gust sends you to the ground. You crawl toward the back door. It takes you a lot of effort just to pry it open. Once inside, you get to your feet and sneak a peek outside. Just clouds of dust and a deafening roar. Okay, it's time to call for help. It started a month ago. One day, you went out to the garden behind your house. It was a windy day. You even spotted a tiny tornado under your apple tree. It hardly reached your knee, lazily swirling around tree leaves and dust. You tried to make it disappear by poking it with your foot. But even after several attempts, the mini whirlwind just didn't want to break apart. You shrugged and went back home. The next day, the tornado was still there, and had it grown? Interestingly, instead of growing taller, it got wider. At that moment, it started munching on your flowering shrubs. You got curious and decided to keep track of this unusual phenomenon. You measured it every day and carefully wrote down all the information in a special notebook. Maybe later I'll write an article or even publish a book about my storm, you thought. One day, you got out of the house to find your favorite apple tree broken. You couldn't figure out how it happened. The storm still looked harmless and too weak to damage a rather large tree. But after this accident, you started asking yourself if not calling for help was the wrong thing to do. Apparently, it was, because just a month later, your mini-storm has suddenly grown to twice its original size. It's unsafe to go outside now. It seems as if your house is in the middle of a real tornado. You can't see the sky behind a wall of dust and debris. Your garden is ruined, trees broken, bushes and shrubs pulled out of the ground and sent flying somewhere far away. You hear your doorbell ring. A group of scientists you invited has come to the rescue. You show them the garden with your personal natural disaster and enjoy their stunned silence. But after a couple of seconds of initial shock, they spring into action. Ignoring the howling wind, they start carrying inside different equipment. It looks very complicated. Your kitchen turns into the researchers' laboratory. You get informed that your house will be temporarily used by the scientists. You take your things to the smallest bedroom and watch the professionals work. Your kitchen is filled with beeping gadgets and devices covered in flickering lights. People in protective suits and lab coats scurry around. Surprisingly, they don't bump into each other. Neither do they create traffic jams. You bring the notes you've been taking and hand them to an elderly man in a white lab coat. He thanks you as if you've just given him the gift of his dreams. The next several days pass in a flurry of activity. The storm in your garden is growing. The scientists seem to get gloomier every time you see them. It's around 2 a.m. when something wakes you up. You blink your eyes open and realize the house is shaking. Your homegrown tornado must have gotten so big, it's reached the house. In the morning, several scientists pull you aside to tell you the unpleasant news. You have to move out. The storm is indeed growing. Soon, it'll wipe your house off the face of the earth. Nothing can be done. You're gaping at the people telling you to get out of your house. Where will you go? They tell you they're building an additional research lab not far from the place. It's important to be able to observe the storm in real time. Anyway, there's a spare room with everything you may need in that facility. Why don't you stay there for a while? It would also be convenient for the scientists. They may need you to answer the questions that appear during the process. You agree because you don't have any other choice. The researchers help you transport your stuff to your new accommodation. You walk around your house, saying goodbye to your favorite coffee table, your sofa, and your cozy bed. The scientists tell you that there's no time to move your furniture to another place. The next day, you wake up to the news that your home is gone. The storm gulped it down at around 4 a.m. Over the next few weeks, the grown-up whirlwind has swallowed 2 houses of your neighbors, the nearby forest, several abandoned cars, and a small flower store. It's now so big, it's coming close to a large lake several miles away from the town. People get evacuated. The authorities have announced a state of emergency. One day, you notice that scientists are talking in hushed voices. They look even more worried than usual. You corner one of them and try to find out the truth. Soon the scientist spills it. The researchers have got some evidence that confirms their worst fears. According to all their estimates, the storm that once started as a tiny tornado in your garden is going to grow into another great red spot. Only on Earth. Crimson-colored clouds are spinning counterclockwise at an incredible speed. Beneath them, you can see vibrant hues of the largest planet in the solar system, the gas giant Jupiter. Those clouds are called the Great Red Spot. It's a colossal storm raging in the atmosphere of Jupiter. If you found yourself at the storm's center, the winds would be rather calm there. But on the edges, the storm's speed can reach 425 miles per hour. That's twice the speed of the fastest and most severe hurricanes on Earth. Over the decades, the size of the red spot has been changing. Right now, it's 1.3 times as wide as our planet. The storm's roots go as deep as 200 miles into the planet's atmosphere. The average tropical cyclone on Earth usually stretches for no more than 9 miles from the bottom of the storm to its top. The unique phenomenon on Jupiter has existed for so long because the planet doesn't have a solid surface. It consists of layers of clouds made up of vapor, water ice, and ammonia. Underneath, there might be an ocean of liquid hydrogen. Our planet is solid, and hurricanes slow down and break apart once they go low enough to touch the surface. But the Great Red Spot has nowhere to make landfall. That's why it keeps raging. The scientist also tells you the most bizarre and alarming thing about the storm in your garden. Instead of growing weak and disappearing many weeks ago, it's not only still going, but it's also getting bigger and more powerful. Even the most experienced specialists can't explain this phenomenon. After analyzing it for days on end, they've come to the conclusion that it shouldn't have appeared on Earth. It's against the laws of nature. Interestingly, the storm's composition is a bit similar to that of the Great Red Spot. You're impressed, but still can't get why the researchers look so worried. It turns out that your once mini-storm is likely to grow as large as that on Jupiter. But since Earth is way smaller than the colossal red spot, it's likely to swallow our planet whole. It'll grow and grow, wiping out towns and cities, forests and highways. At the same time, it'll become more powerful. People will have to leave their homes and get evacuated to relatively safe areas, until there are no more safe areas left. This process will take years, but it'll still be too fast for people to prepare. There will be two ways to deal with this global problem. One of them is to colonize the moon or another planet, for example, Mars. But it's an incredibly long process, and the storm will conquer the entire planet before the first spacecraft with people leaves Earth. Or scientists may try to stop the hurricane. There's a technology called the sunglasses effect. Billions of tons of dense gas get pumped into the atmosphere. This gas absorbs sunlight and cools down ocean water, which is the engine of any hurricane. The researchers aren't sure if this method will work with your storm. It formed not over the ocean, but in your garden. Early Earth might have been purple, not green. There's a theory that ancient microbes used molecules other than chlorophyll to absorb sunlight. These molecules likely gave living organisms a violet tint. Scientists are almost sure that our planet once had 2 moons. One of them was a tiny thing, no larger than 750 miles across. Unfortunately, it crashed into the other moon, which is now Earth's only natural satellite. Until recently, there was one more object orbiting our planet. It was a temporary mini-moon called 2020 CD3. This tiny space rock, no bigger than 3 feet across, was pulled into our orbit more than a year ago. Astronomers believe the mini-moon left Earth's orbit in March. From 60 to 100 tons of space dust drift down to our planet's surface every day. These tiny cosmic particles are mostly released by comets, which are usually made of dust and ice. When the sun turns this ice into vapor, the remaining dust travels down to Earth. If you look at Earth from space, you'll see a blue ocean planet. Almost 70% of its surface is covered with water, and its average depth is 14,000 feet. But if you gathered all the water into a sphere, it would be a mere 870 miles across, just barely enough to cover Texas. And that's including all the water in the seas, oceans, rivers, lakes, ice caps, groundwater, and even those tiny droplets in the atmosphere. All Earth's air, yep, all 5,140 trillion tons of it, would make a slightly larger ball. By the way, the further away from the surface, the less dense the atmosphere is. That's why half of Earth's air is within the first 3 miles above the surface of the planet. Every 200,000 to 300,000 years, our planet goes through a magnetic pole reversal. It's not an instant process, though. It can last hundreds or even thousands of years. We live inside the sun. Its atmosphere stretches far beyond its visible surface. And even though Earth is 93 million miles away from the star, it's still within the reach of the sun's atmosphere. Auroras happen when charged particles from the sun get caught by Earth's magnetic field and crash into the upper atmosphere near the poles. The Hudson Bay of Canada is a gravitational anomaly. This area has lower gravity than any other place on Earth. You'd weigh less standing at the equator than at one of the planet's poles. Mars has only 15% of Earth's volume and less than 10% of its mass, and still, the red planet and Earth have almost the same landmass. It's because about 2/3 of our planet's surface is covered in water. The Pacific Ocean contains more than half of the world's free water. It's also by far the largest ocean. All Earth's continents could easily fit into the Pacific Basin. Our planet is gradually slowing down the speed of its rotation. It happens at an unhurried pace of 17 milliseconds per 100 years. Because of this, our days are becoming longer. And still, only after 140 million years, the day on Earth will last 25 hours. The ocean on Jupiter isn't made of water. It's filled with metallic hydrogen, and its depth is a staggering 25,000 miles. That's actually almost the same as the circumference of Earth. A year on Mercury is just 88 Earth days long. This planet also has an extremely squashed orbit. Its distance from the Sun varies from 28 to 43 million miles. Even when you're standing, sitting, or lying still, you're moving at more than 1,000 miles per hour. That's the speed at which our planet is spinning through space. At the same time, you'd be moving at this incredible pace only if you're at the equator. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, the atmosphere of Earth. It also has more than 20 layers. All of them are cold and condensed. Methane gas is a byproduct of natural processes, and this very gas is present in the Martian atmosphere, which confuses astronomers to no end. Mars produces around 270 tons of methane per year. Scientists can't figure out where the gas is coming from. Earth's southernmost continent, Antarctica, is only the 5th largest one, but it contains almost 70% of the planet's fresh water and 90% of the world's ice. Antarctica is also considered to be a desert. The inner regions of this continent get just 2 inches of precipitation a year, in the form of snow, of course. Mercury's surface is wrinkled. It happened when the planet's iron core cooled down and contracted. The wrinkles can reach a height of 1 mile and stretch for hundreds of miles. Lots of rocks on Earth have a Martian origin. Scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places, and it turned out these rocks had arrived from the red planet. The only asteroid belt in the solar system astronomers know about lies between Mars and Jupiter. There are thousands of asteroids in this region, but they're extremely widely spaced. If you had to go through that area, the chances of colliding with an asteroid would be almost non-existent. The 4 largest asteroids, sometimes called minor planets, contain half the mass of the entire belt. And still, the total weight of all the asteroids there is a mere 4% of the Moon's weight. Mercury is the most cratered planet in the solar system. Its craters are named after famous musicians, artists, and writers. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. The origin of this valley puzzles astronomers. After all, Mars isn't a planet known for its active plate tectonics. Atmospheric pressure on Venus is 92 times greater than that on Earth. Venus also has a much denser atmosphere. That's why only big meteorites can make it to the planet's surface. The smaller ones get slowed down and fall into pieces before reaching the ground. Our planet has its magnetic field thanks to scorching hot liquid metal that's flowing inside its outer core. This creates electric currents, and they, in turn, generate the magnetic field. For the past 200 years, the planet's magnetic North Pole has moved northward for about 600 miles. These days, it's traveling faster than it used to, 40 miles per year versus 10 miles per year several decades ago. Volcanoes on Pluto, which are called cryovolcanoes, spit not lava, but ice. Instead of molten rock, they erupt water, methane, and ammonia. Jupiter's mass is twice greater than the mass of all the other planets in the solar system combined. Earth is the densest planet in the solar system, but this density varies depending on the planet's part. For example, the crust is less dense than the solid metallic core. Saturn's upper atmosphere is divided into layers of clouds. Those at the top are made of ammonia ice. Then, there are water ice clouds, and below them, layers of sulfur ice and cold hydrogen. Uranus rotates on its side. The reason for such an unusual position could be a powerful ancient collision, but so far, it's just a theory. By the way, Uranus is the only planet sitting on its side. Venus rotates in the opposite direction to the Sun. The reason might be a powerful collision with an asteroid or another space object. Iapetus, one of Saturn's moons, has an unusual coloring. It's two-toned. One of its sides is dark with a slight reddish hue, while the other is bright. Scientists haven't cracked this mystery yet. Jupiter's moon Io has hundreds of active volcanoes on its surface. It's the most volcanically active body in the entire solar system. The moon is covered in lava lakes and plains of liquid rock. Plumes of sulfur spew up for almost 200 miles. It takes light more than 4 hours to travel from the Sun to Neptune. Of all the planets of the solar system, Jupiter has the shortest day. It lasts for 9 hours and 55 minutes. Such a rapid rotation speed gives the planet its slightly flattened shape.